Now part B is about the Pearson's product moment correlation coefficient. As you remember, in part A, we said that it's all subjective to call it, strong, moderate, or weak. We need something more accurate one. We need a number. So actually, the Pearson himself, he found the formula with the pairs, with the data which we had. He actually made a formula. You don't need to memorize the formula. It will be, okay, you will use your graphic calculators to calculate it. It just, when you find the number, you need to understand what does it mean. So when this coefficient is between, will be always -1 and 1. The sign indicates that when you have negative, it means you have negative correlation. If it's positive, you have positive correlation. What's positive and negative is, one more time, positive, the increase in independent variable will lead to increase in dependent variable. Negative correlation is increase in independent variable will lead to decrease in independent variable. And when you have r equals to 0, means that there is no correlation. So just straightforward. And also the strength, whether it's a strong, weak, or moderate, depends on the number where it is. So in your book, there is a given table. You don't need to actually memorize it, because in some, let's go with the more detail. When r is 1, it's a perfect. Okay, no doubt with that. If we have 1, it's a perfect correlation. But in some books, they give this part. So you just mainly need to figure out that if it's more than 80, if it's more than 8, it gives a very strong. If it's, we need just 3 cases, strong, moderate, and weak. If it's more than 80, it's a strong. If it's between 0.5 and 0.75 or 0.8, in some book they take 0.8 and also 0.75, so 75% like. If it's between 0.5 and 0.75, then it's a moderate. If it's smaller than 0.5, it's a weak correlation with the positivity and negativity. So just remember this one. Let's try to see how it works. I will try to show with calculator. Here, this question from your book. Here is a two data, number of supermarkets and the number of car accidents. Okay, what's the relationship between them? So they just collected some data in a specific town. So they first say draw a scatter diagram. So we know how to draw a scatter diagram. Just need to go with the X and Y. And for the X, let's put the supermarkets and the car accidents, let's say. Because I don't know for sure now what's the dependent, independent. I just put them randomly. And I put my points. Okay, here we can do it the same with calculator. What do? We go to the statistics. Then we go into, then here, as you can see, list, I need to input the numbers. So let's put the numbers. What were they? 5. I will go quickly. 8. Number of supermarket 12. 7. 6, 2. 6. And 2. 15. And 10. 3. Then we go with the car accidents. 10. I hope I did input them correctly. So in your calculator also you can see it. What do we do next? We go to graph and let's go with the second. They will show the same. Here you have the scatter diagram. When you draw it by hand, you should get the same result, the same picture. So from here, just from seeing it, what do you think it is? It's a positive. There is a positive correlation, of course, but I need the number to decide whether it's strong or not. Then I go to the calculation and X here. For now, just we need these R, these Pearson's coefficient. This one is R. This one we are going to use. So what do we see? It's a, what was it? 0.5715. So approximately, I need three significant figures, 5, 7, and 2. So what can you say about this correlation? It seems almost weak, correct? Or okay, it's a moderate, but almost weak. So it's a positive, moderate correlation. We did calculate this one. We drew it. I showed the graph now. Identify the outlier of the data. Outlier here. What was the outlier there? If I go to the graph, outlier is this guy. Which guy is this? With the, what's the number? Is it? The 3 and 37. Yes, the outlier is 3 and 37. So 3 supermarket and 37 car accidents. Part D, it was found that the outlier was due to an error in the data collection process. So that was error. That's why its outlier looks now also in the picture. Let's remove it and let's see what will happen to the my coefficient, how it will have effect. So let me find it. Let me just delete 37 if I can. Okay, let's also 3. We need to delete it. And now let's see it again. Here I removed it and let's calculate it again. Go to the X. And here my correlation is 0.92. Do you see how it affected my whole process, my conclusion? 0. What was it? 928. So as you can see now, I have positive, strong correlation. Now, because of this outlier, we also might have in our research, it affects our results. Describe the relation between the variables. So what kind of relation? We just said positive, strong relationship, correlation. So discuss the effect of removing the outlier. So it had a tremendous effect on my result. Look at the difference. Almost weak to the strong. And now, last one, do you think that there is a causal relationship between the variables? Explain your answer. Of course, there is no causal relationship between supermarkets and the car accidents. They must be dependent on something else in a specific town. On what? Of course, on the people. The number of people in that town. These number of people caused all these. The number of supermarkets and the number of car accidents. So there is no causal relationship. No causal relationship. If it were causal relationship, what we'll say? The independent variable explains or causes the dependent variable, or explanatory variable leads to the response variable. The definitions just.